Hi guys, welcome back to Technovizard. So today I'm gonna discuss the 5 most important questions of the control system. Okay, so also you can follow us on Facebook, Telegram, Instagram, and YouTube channel for the latest job notifications. So let's get started. So this is our first question. The control system, the closed loop transfer function of a unity negative feedback system is this 100 divided by s square plus 8s plus 100. Its open loop transfer function is, so we know that in the control system the transfer function of a closed loop transfer function, so I'm writing closed loop transfer function, is given by c of s by r of s. This is equal to g of s divided by 1 plus gs into hs. So this is the formula for the transfer function in case of closed loop transfer function for the negative feedback. Okay, so now in the question it is saying that it's unity negative. It means here the h of s value is 1. So now we have to find out the open loop transfer function. So simply the open loop transfer function will be given by g of s. Okay, so because hs value is 1, so we have to find out the value of gs. So now let's substitute the value here. So this is g of s divided by 1 plus g of s is equal to 100 divided by s square plus 8s plus 100. So we can easily find the value of gs by cross multiplying and then simplifying the equation. But I'm gonna solve this using a shortcut or a trick. Okay, so trick is, whenever you have to find out the open loop transfer function from the closed loop transfer function, you have to keep the numerator as it is, and in the denominator you have to subtract the numerator. So on the numerator we have 100, so 100 will remain as it is. Denominator is s square plus 8s plus 100, so you have to subtract the numerator. So we are simply getting 100 divided by s square plus 8s. So this is the answer. Okay, so this is the value of open loop transfer function. So it means option D is the correct. So now next question is, consider the following statements with regards to the signal flow graph. The number of loops are 3. So now we have to, number of loop is nothing but the closed path. So now we have to find out the number of loops present in this signal flow graph. Also we have to find out the number of forward path. So number of forward path is the path available to move from the input. This r is the input and c is the output. So we have to find out the number of path available from the input to the output. Okay, also we have to find out the c by r is the transfer function. Okay, so now first of all we can find the value of the transfer function using the Mason's gain formula. Okay, so first of all let's find the number of loops present in the signal flow graph. So suppose I'm starting from here, so this is loop 1. Okay, and this is another loop, and this is loop another loop. So it means total loop present in the signal flow graph is 3. Okay, so I'm again repeating. So this is loop 1. Okay, this is another loop, and this is third loop. Okay, now next is we have to find out the number of forward paths. So start from here, so you have to see how many paths are available. So this is path 1. Okay, this is another path, and this is another path. It means forward path available is also 3. Okay, so forward path is 3. So now we have to find out the transfer function. So simply we'll solve using the Mason's gain formula. Okay, so Mason's gain formula. So basically Mason's gain formula is a technique to reduce a signal flow graph to a single transfer function, which is given by g of s. This is equal to c of s divided by r of s. This is equal to summation delta of pk. Oh sorry, this will be pk delta k. Okay, so this will be equal to summation p of k delta k divided by delta. So now where k is the number of forward paths which we have calculated is 3. Okay, so k is the number of forward path. Next is p of k is the kth forward. So P of k is the kth forward path gain. Okay, so forward path gain, and delta is equal to 1 minus summation, that is sum of all the loop gain present in the system. Now this will be plus summation of non-touching loops, non-touching loops loop gain taken two at a time. Okay, taken two at a time, then minus this will be summation non-touching loop taken three at a time, and so on, taken three at a time, and plus this will be so on, and delta of k is given by 1 minus the loop gain which does not touch the forward path, which does not touch the forward path. So now I'm gonna solve this. So this will be, so I'm writing here, okay, so that you can easily see from the diagram. So we have to find out the transfer function. So this will be equal to C of s by R of s. So now first of all consider one forward path. So I'm taking this, okay, so I'm moving like this. So you have to find out the gain of the forward path. So for the gain you have to simply multiply. So this is the gain, so overall gain of this forward path is that you have to multiply. So this will be simply 8. So this is 8. So now see that this forward path is touching all the loop. So yeah, this forward path is touching all the loops present in this signal flow graph. So this will be 1 because it is touching all the loops. Next forward path is, suppose this is, so now this forward path gain is 5 into 4 is 20. This is also touching all the loop, this will be plus 1. Next is this forward path, so this is 12, this is also touching all the loop. Now this divided by 1 minus the sum of all the loop gain. Okay, so suppose I'm starting from here, so this is one loop, so the gain of this loop is 4 into 3 into minus 2, so this will be equal to minus, this will be 24. Okay, now next loop is also negative, so this will be 4 into 2 into minus 2, so this will be equal to minus 16. Similarly this will be 5 into 4 into minus 2 is minus 40. So you can simplify this. Now next is you will write plus, because there is no non-touching loop present, so that's why I'm not writing. Okay, so now you can simplify this. This will be 20 plus 8 plus this will be equal to 40, this will be equal to 1 minus, and this will be equal to minus of 80. So simply we are getting the value of transfer function C of s by R of s as 40 divided by 81. So it means statement 1, statement 3 and statement 4 is present. So 1, 3 and 4, so option B is correct. Okay, so now next question is, for the polynomial P of s is equal to s power 5 2 plus s power 4 plus 2s cube plus 2s square plus 3s plus 15, the number of roots which lie in the right half of the s-plane. So simply we can solve this type of questions by the Routh-Hurwitz criteria. Okay, so Routh-Hurwitz criteria. So now in this we have to solve. So now we will see how many sign changes are there in the first column of the Routh array. Okay, so let's solve this. So in the RH criteria we write like this is s power 5, this is s power 4, we write the power of s in the decreasing order. So this is s power 3, this is s power 2, this is s power 1, this is s power 0. So now substitute the values alternatively. So this will be 1, then alternate value is 2, then is leave this 2, this will be 3, then come to the next row, this will be equal to 1, this is 2, and this is 15. So now we have to find out the value of the first column of the third row. So this will be simply 1 into 2 minus 1 into 2 divided by 1. So this will be equal to 2 minus 2. So this will become, so this is becoming 0 because 2 minus 2 divided by 1 is 0. So next is this 1 into 3 minus 1 into 15 divided by 1. So this will be equal to 3 minus 15 divided by 1. So this is coming equal to minus 2. No term available, so write it 0. Okay, so now this is a special case. So whenever the first entry of any row becomes 0, so we have to consider that entry as epsilon, where epsilon is a small positive value which is tending to 0 positive. Okay, so epsilon is a small positive value tending to 0 positive. So now you have to solve or fill all the remaining entries using the epsilon only. Okay, so now this will be 2 into epsilon. Okay, so this will be 2 into epsilon, minus of minus 12 will be plus 12 divided by epsilon. Okay, so this will be epsilon into 15 minus 0 by epsilon, so this will be 15 and this will be 0. So suppose I'm taking this term as denoting it with x, okay, for the easier convenient. Okay, so now further simplify this, so this will be equal to s1 is minus 12x minus 15 epsilon divided by, this will be equal to x. So now this will be 0 minus 0 is, this is also 0, this is 0. So now this will be this term minus 15 minus into 15 minus 0 by this, so this will be equal to 15 and all other entries are 0. So now see, so see the sign of the first column only. Okay, so now s5, so I'm writing here. Okay, so the first column of s5 is positive, s4 is 1, so this is also positive. So s3 is epsilon, so already told epsilon is a small positive value, so it is tending to 0 positive, it means this is positive. So third column is also positive. Now this is x, so now we have to solve for x, so where x is equal to 2 epsilon plus 12 by epsilon. So this epsilon is positive. Okay, this 12 is positive and this is also positive, it means positive by positive, so we are getting x as positive only. Okay, so it means this s2 is first column is also positive. Now see this x, so I'm taking another color pen, suppose this. So now let's simplify this. So this is minus 12x, we have to find out its sign. Okay, this divided by x, so now x is positive, so this is negative into positive is negative, epsilon is positive and this is positive. Okay, so this is negative into positive is negative minus negative, so overall this will be negative, so it means we are getting this term as negative and 15 is positive. So now see the sign change, so first sign change is from this positive to negative, we are changing from positive to negative, then again from the negative to positive, it means total 2 sign changes are there. Okay, so total 2 sign changes are there, so it means 2 roots will lie in the right half of the S plane, so option B is correct. Okay, so now see the next question. A system is described by the following state and the output equation. So this is the equation where u of t is the input and y of t is the output. So we have to find out the system transfer function. So system transfer function is nothing but the Laplace of the output by input. So we have to find out the ratio of y of s by u of s. So simply this equation is of the differential form, so we'll solve this by taking the Laplace transform. Okay, so let us, I'm denoting this as equation 1, this is equation 2, so solve equation 1 first. Okay, so I'm taking the Laplace transform of equation 1, so this will become s into x1 of s, as no initial condition is present, so this will be minus 0. This will be equal to minus 3 into x1t, Laplace is x1 of s. This will be plus x2 of s, and 2 u of t, Laplace is u of s. So now combine x1s term, so this will be equal to s plus 3 into x1 of s is equal to, this is equal to x2 of s plus 2 into u of s. So from here we can find the value of, so let it be like this. So suppose this is equation 1. Okay, so now take the Laplace transform of equation 2. This will be equal to s x2 of s is equal to minus 2 x2 of s plus u of s. So now take x2 of s common, so this will be equal to s plus 2 x2 of s is equal to u of s. So from here we can find the value of x2 of s. So this will be equal to x2 of s is equal to u of s divided by s plus 2. So suppose this is equation 2. Now this is our third equation, so also take the Laplace transform of third equation. This will be equal to y of s is equal to x1 of s. So this is equal to y of s is equal to x1 of s. So this is equation 3. So in place of x1 of s we can simply put y of s. So we have obtained equation 1 as, equation 1 was s plus 3 x1 of s is equal to, this was x2 of s plus 2 u of s. So in place of x1 of s we can write y of s. So this will be equal to s plus 3 into y of s. X2 of s, from the equation 2 we can write it like this. This is u of s divided by s plus 2 into u of s. So now we can simplify this. So this will be s plus 3 into y of s. So I am taking u of s common, so this will be equal to 1 upon s plus 2. This is plus 2. So simply we have to find out the value of y of s by u of s. So this will be equal to 1 by s plus 3. So I am taking s plus 2 as the LCM, so this will be equal to 1 plus 2 into s plus 2. So this will be equal to, this is 2s plus 4 plus 1. Okay, so this is 1 plus 2 of s plus 4 divided by, this is s plus 3 into s plus 2 is s square plus 5s plus 6. So we are getting the value as 2 of s plus 5 divided by s square plus 5s plus 6. So this is the value of the transfer function. So it means option C is right. Okay, so now next question is, the state space representation of a system is given by x dot is equal to, this is of the form x dot is equal to ax plus bu and y is equal to cx plus du. Okay, so this is the state space representation. So it means this matrix is A, this is B. This question has correction that y matrix here is like this. This is not vertical, this is horizontal value. Okay, so now we have to find out the transfer function of the system. So for the state space representation, the transfer function formula is given by c of s by r of s. So this is equal to c into si minus a inverse into b plus d. Okay, so this is a matrix, this is b, and this is the value of c. Here no matrix for the d is available, so it means the value of d is 0. So now we first simplify this. So we will find the value of si minus a inverse. So first solve for si minus a. Okay, so s, here I is the identity matrix of the order 2 cross 2, so this will be equal to s0 0 s. Okay, so now we have to subtract a matrix is minus 1 0, this is 0 minus 2, so this will be equal to s minus or minus 1 is s plus 1, this is 0 minus 0 is 0, this is 0 again 0, and this will be equal to s plus 2. Okay, so this is the value of s I minus a. Now we have to calculate its inverse. So its inverse will be equal to adjoint of a divided by determinant of a. So the determinant value will be equal to 1 by s plus 1 into s plus 2, and its adjoint is the main diagonal will change the position and the non-diagonal sign will change, but 0, negative 0 will remain 0 only. So this is the inverse of si minus a inverse. So now we will pre-multiply with c and post multiply with b matrix. So here C matrix is 1 1 and this B matrix is 1 0. So substitute here. So C matrix was 1 1 and Si minus A inverse we have obtained is, so this will be, first of all we have calculated 1 divided by, this is s plus 1 into s plus 2, and this will be equal to s plus 2 0 0 into s plus 1, and this is the value of b, this is 1 0. So now we can take this to the outside, so this will be equal to 1 upon s plus 1 into s plus 2. So this will be 1 1. So now simplify this. So this is 2 cross 2 and this is 2 cross 1. So we will obtain 2 cross 1. So s plus 2 into 1 is s plus 2 plus 0, and this will be equal to 0 plus 0. So this is 0. So now this is 1 cross 2, this is 2 cross 1. So we will simply obtain 1 upon s plus 1 into s plus 2. So multiply this. So this will be equal to 1 into s plus 2 plus 0. So it means simply we are getting the value of transfer function as 1 upon s plus 1. So 1 upon s plus 1. So option D is right. Okay. So yeah, thank you guys for watching this video. Please like, share and subscribe to the TechnoWizard YouTube channel.